This video is an explanation of how to find the arc length of a sector of a circle. So in order to think about arc length, we first need to think of the concept it's based off of. Arc length has its foundation in circumference. So we know from the past that the circumference formula is pi d or 2 pi r. 2 pi r is going to be the formula that I work with as I move forward. Before I continue any further, I just want to give you a reminder. We've talked previously that I can use the symbol theta. It's a Greek variable, and it's just a Greek variable that represents an angle. So you're going to see this pop up in a second. So I just want to make sure I review that first. So a variable that represents an angle. So the x's and the y's were used to represent numeric quantities, lengths, etc. We use theta to represent unknown angle measures. Okay, so next, the concept of arc length. Basically, the definition is, or formally, it's the linear length of a piece of the circumference that is subtended, which means cut off by a central angle. So the translation of that definition is basically just, it's a fraction of the circumference. So I just need to figure out what is that fraction? Where am I figuring out that fraction? So usually when we're working with arc length questions, we are given information about, or we have a circle. It's either given us in diagram or explained to us. And in that circle, there is some angle that subtends or cuts off a piece of the circle. So this blue angle is subtending an arc. So if I call this intersection of the angle in the circle A and this one down here, arc AB will be this guy, and that's going to be the arc length that I'd be talking about. It is subtended by this angle, and I'm going to say the measure of this angle is theta, some angle measure. Now, if we are in degrees, I can say the arc length, and S is actually the letter that we use to stand for arc length. So I can say S equals some fraction of my circumference, which is 2 pi r. The question is, how do I express that fraction? So if I look at this, we know that if it's half of the circle, it would be 180 out of 360. That's where we get the half from. If it was a quarter, it would be 90 out of 360. But I don't know what it is. It's just theta. So I'm going to say the area, the formula for the arc length, if I have my angle given in degrees, is whatever theta is over 360 degrees. If that makes sense. So theta over 360 represents the fraction of the total circumference. Now, if I am in radians, I have two things I could do. One, I could try to convert the formula in degrees, but the easier way is just think about it. If theta is in radians now, or there's 2 pi radians in one rotation, I can now say that my arc length formula is S equals some angle theta over the whole circle, which will be 2 pi radians times 2 pi r. But when I look at that, this first thing is a fraction, so I can write the second one as 2 pi r over 1, and when I do that, something cool happens. The 2 pi in the denominator of this fraction is going to cancel out with the 2 pi in the numerator of that fraction. So this equation simplifies pretty drastically to just being S equals theta r, or more commonly said as S equals r theta, where S again is my arc length. R is the length of my radius, and theta is my angle measure. So it's very important that you remember that you have to pay attention to the units that are given on your central angle. Because if your central angle is in degrees, then you're going to use this formula here, where it's theta over 360 degrees. But if I'm in radians, then I would want to use this guy here, because this is a simplified version of the formula if we are given radians. So we can look at a couple of examples to kind of see what's going on here. Let's see if I can do that. So I can do something pretty simple. Okay, let's take a look at a couple of examples. Example 1. If the arc length of a circle subtended by an angle measuring 3 radians is 12 centimeters, how long is the radius? Now I know this isn't in your notes packet, but you can just take a second and jot this down in a space on your notes packet. So you can pause it now and do that. Okay, so what we're going to do is look at the question and figure out what formula do we need, what variables do we know the value of, and what variable are we solving for. So as I kind of read this critically, they tell me the arc length of the circle, blah, 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 is 12 centimeters. The arc length is subtended by an angle that measures 3 radians. The fact that that's radians is important because now we know which formula we need to use. And my unknown is the radius. So we currently know that arc length, which we said is S, equals 12 centimeters. We know that the angle, which we said is theta, equals 3 radians. And my unknown is my radius. So because it's arc length in radians, I know that my formula is S equals R theta. And I'm going to plug in what I know. So I know that 12 equals R times 3. I'm getting that from the values that I found in my question stem. I think everyone can see that if I divide by 3 on both sides, I get R equals 4. So my final answer is that the radius has a length of 4 centimeters, same units as the arc length. So the calculations aren't that hard, it's just a matter of figuring out what variables are given, what we're looking for, and which formula. In our second example, we have a radius of a circle is 2 feet. So radius is 2 feet, so I know that R equals 2 feet. And I know that the arc length is 8 feet, so arc length we said is S, so S equals 8 feet. And I want to know what is the measure of the central angle. So theta is our unknown. That's what we have to solve. Again, I am not sure if I want radians or degrees. If it's unclear, you can pick. I'm going to choose the easier formula. I'm going to choose to say that S equals R theta. I didn't say who was radians or degrees, so I'm going to go with the easier one. And I'm going to plug it in. 8 equals 2 theta. Divide by 2 on both sides, and I get that theta equals 4. Because I use this, the answer is theta is 4 radians. And just regular old 4, not 4 pi, because that's around 12, actual 4. If I had to do this guy in degrees, my only difference is I would use the formula S equals theta over 360 times 2 pi r, which clearly is a much more annoying formula. We can do that though, just to see how it would go. So I would say 8 equals theta over 360 times 2 pi 2, which is just 4 pi, 2 pi 2, which multiplies to 4 pi. To figure this out, I need to multiply both sides by 8, or by 360. Sorry, don't know why I said 8 there. When I multiply by 360 on the right-hand side, I get theta times 4 pi. And on the right side, I get 360 times 8, which is 2,880. Divide by the 4 pi. Units of degrees. And that's my exact answer for theta. If I wanted the approximate, I would plug that into my calculator. And that's arc length of a circle in both degrees and radians.